This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Alright, this is the formula for making chlorine, right? Uh, these are the molar masses. I only have 68% of my product is actually calcium hypochlorite, so I divide by 0.68. I get 210 grams. Over here, 71 times 2, because there's 2 moles, 142 grams. I only want to make a half a mole. So I took everything in half. Took this in half, took this in half. So now I only need 105 grams of hypochlorite to make 71 grams of chlorine. The hydrochloric acid is concentrated, so it's 1 mole for every 100 milliliters. There's 4 moles, so that'd be 400 milliliters, but we're only going to make half, so I took down to 200 milliliters. Now here's the chlorine. Remember, we made 1 mole, 71 grams. So how much sodium bromide do we need? We need 2 moles of it. 1 mole is 103 grams, times 2 is 206 grams. Now this could be a dihydrate. I didn't even figure it out. I just figured, hey, if I have extra, that's okay. It erased here, but 18 times 2 is 36 grams, because 1 mole of water is 18 grams, right? And it dihydrates 2. 36 grams. Add that to my 206. So I'm going to add 242 grams of sodium bromide. I'm going to add it into 200 milliliters of water and dissolve it first. That way I should have a theoretical yield of 160 grams of bromine, which is 51.6 milliliters, because it's really dense. Alright, here's my setup. Basically set up for a simple distillation. You can see up on top I got a thermometer up there. Got a little sidearm here so I can add stuff. I got my 105 grams of calcium hypochlorite in here. I got 200 milliliters of water in here with 242 grams of sodium bromide, just in case it's a dihydrate. It's actually starting to turn a little orange right now, a little red. But we're going to get that sidearm. We're going to put some equalizing funnel in there and put some hydrochloric acid in. Alright, so I'm going to drip in a little HCl, see what happens. It's turning it red. Well, I'm just going to add that and see how it goes. As soon as I started adding stuff, it's heated up. And so I put an ice bath on it. You can see. I don't want to make the chlorine, and then the chlorine escapes before it has time to turn into bromine. You know what I mean? And I'm adding concentrated hydrochloric acid to water, so you know that's exothermic. So that should keep it down until I add it all. You can see it's getting red. There's no chlorine or anything in the rest of the apparatus. Well, I'm about halfway through adding. Got my drip rate. Actually, it's kind of slow right now. I should speed it up. But I want you to know what's happening here. I'm dripping this HCl into this pot. It has the hypochlorite. Remember calcium hypochlorite? That liberates chlorine. And just like a more active metal, you know, you can put iron into a copper sulfate solution and the copper will come out because the iron is more active, you know what I mean? It wants to react more. Well, this is the same here. One halogen is more reactive than the other halogen. So the chlorine wants to be with the sodium. It wants to be the sodium chloride. It liberates the bromine. Keeping down the fumes, you can see they only go up to about right there. Well, it's starting to go through the apparatus now. We have a little bit left. Turn the drip rate up higher. That's why it's doing that, but it's almost done, so let's do it. Definitely right in there. Got my bubbler going. Well, all I had to do to get that gas out of there. Yeah, it's all cleared up. Put this on an ice bath. And I threw some water in there so it'll soak up any gas, right? Turn my condenser on. And I let the water go through it. I didn't keep it on. I just let the cold water go through there. Now it's stuck in there. And that basically took all the gases out. See, it's nice and clear again. I'm almost done here. I just got this much here. It's taking forever though to do this. So I got it going. See how I based through it with the water from the ice bath, right? See? Helps calm down the fumes. Well, things are starting to lighten up. You can tell. Basically just trying to get it up to temp now. This magnetic stir bar thing I have, hot plate, it sucks. It can't boil water, for God's sakes. So it's almost done. Because I used a stupid heat stir plate, I couldn't get the water out of there. I couldn't get it up to boil the water to get all the bromine out. So what I did was, see there? That's either bisulfite or sodium sulfite. I basically just put some aqueous stuff in there and look at that, turned it all yellow. Same over here, just put a little bit in there. You can see the whole apparatus is pretty much clean except for this one little spot here. That way when I open it up, it's not going to be all bromine getting all over the place. I got about 40 40 milliliters. I don't even see any water in it. Keep in mind, I got some solids in there. There's no water in there, but I couldn't get my still head temperature past 45 the entire time, so that's probably why. But like I said, there are solids in there. Keep in mind, I do have ventilation in here now for these types of experiments. So, I mean, these are really nasty gases, chlorine and bromine. It's hard to contain it, so I got to use it as soon as I make it. You can see I got it in a bottle here that I put plastic over it, saran wrapped it a few 100 times, and I put some paper around it, and I saran wrapped it again, so I know if that paper turns brown, I got a leak. You know what I mean? I need to saran wrap it some more. I put it in a freezer. Do not put it in your food freezer. It will get out, even if you don't think it's getting out. It's getting out, and it's getting on your food. Now, I did say that there's no water in the bromine I got. That's not true. I mean, I put water in there to collect the gases up, so I know there's water. There is some water that's, soluble in the bromine. If you wanted to get that out, you would have to, I would throw a little bit of salt water in there to soak up any water out that you can get, and then I would get some sulfuric acid and slowly put it in, drop by drop, just a little bit, you know what I mean, to separate it. You'll have to watch someone else's video for that. I think they all show you how to do the sulfuric acid thing. But anyways, I don't care about that because I'm making hydrobromic acid or hydrobromous acid. So I don't care if there's water in it. But other than that, and as for the solids, I don't know if maybe those are trimers or oligomers, like the bromine's like polymerizing into a solid. I don't know what that solid is. But again, I don't care because I'm just going to throw it in some water anyway, and I can get rid of it then. Always remember, science is great.